So as Mark's mentioned, I've come over from Sydney. MS Research Australia is based in Sydney, and thank you to Sue and Marcus for bringing me over and giving me the opportunity to speak to you all today. So I'm the Research Development Manager at MS Research Australia. So it's my job to work with the researchers around Australia. I work with them in large national collaborations to facilitate the research and make sure everything's running smoothly. And it's also my role to communicate the research and the progress in the research projects that we're funding to the MS community. And so that's partly why I'm here today. I'll use this one. Okay. So I wanted today to give you, it is an overview. I'm not going to be able to go into great detail on all of the topics. The field of MS research is a very broad area. There are a very wide range of different research areas happening in MS research, all of which are exciting, all of which are making excellent progress. So I'm just going to try and give you an overview today and not go into huge detail on all of them, but hopefully there'll be an opportunity at the end to if you would like to ask more detailed questions about some of the areas that I've covered. So our goals at MS Research Australia is to, as Marcus said, knock MS over. Let's see if we can get rid of it altogether. We'd like to prevent MS. It's one of our key goals, is to find ways that we can reduce the impact of MS in Australia and in the world. We would like to be able to improve the diagnosis, get people diagnosed sooner, and provide people with better treatments, stronger treatments that work and have fewer side effects. And we also want to be able to undo the damage that MS has already done in many people's nervous systems. So repair that damage, regenerate the nervous system, and effectively cure MS. Now, so those are our research goals. That's what MS Research Australia is seeking to achieve. And sometimes it seems that we use different language, but I think that the language that we use, it is just a different language when we talk about research, because I think the questions that you ask as members of the MS community are the same questions that we're asking in the research community. It's just that we use different words, and it can seem like we're working in a completely different world and not always addressing what you think might be the key problems in MS. But I think when you look at the common questions that are asked by people with MS, and the fields of research that are going on, the two do gel very closely, and we are trying to get to the bottom of it. But it's very, very complex, and there are many different fields that we have to look into to solve the problem of MS. So it's about understanding why a person with MS gets MS, why them and not somebody else, are their family at risk, what's the prognosis? MS is a very complex disease, everybody's journey is different. People respond differently to medications, and we really need to be able to understand why that is so that we can tailor treatment to the individual as best we can and get the best possible outcome for every individual. And as I mentioned, we want to be able to undo the damage. So down the far end of that screen there, you can see the different fields of research that are going on into MS. We're looking at the causes, the etiology of the disease. We're looking at genetics, understanding risk, why some people get MS and others don't. Epidemiology is the study of the environmental factors that contribute to a person getting MS, the population study, if you like, of the population of people with MS, and the things that they have in common and the things that they don't have in common. Biomarkers are helping us to track MS in an individual. A biomarker is simply something in the blood, something on your MRI scan, something that we can measure in your body fluids or in your neurological exams so that we can track very precisely what's happening in MS. Pharmacogenetics is about determining how your genes determine the way you respond to a treatment. And there's some really interesting things I would like to tell you about that happening at the moment. Understanding the way the disease works, the biology of the disease or pathogenesis. We're trying more clinical trials. We're trying to look at stem cells and helping the brain to regenerate itself to cure the damage that's already done. And we're looking and this all takes time. So in the meantime, we need to help people to live well with their MS, to manage their symptoms, and to rehabilitate after the injuries have been done to the brain. So all of these areas are ongoing areas of research in Australia and around the world. Australia has its own strengths, and other organisations in the world have their strengths. So we're all working together to answer those questions. So, as I mentioned, MS is a very complex disease. You are all probably familiar with this, the MRI scan there. Those white spots are the inflammatory lesions that are damaging the myelin. So on the right-hand side there, the blue area is the main areas where the fibres of the nerves go through the brain, and they're insulated by myelin, which is a fatty substance like the plastic around an electrical cable. Stops those electrical cables from short-circuiting and keeps those electric signals flowing rapidly through the brain. Where myelin is lost, those brain signals are slowed down and stopped, and the nerve fibres themselves become vulnerable to damage. So the immune system is involved, the nervous system is involved, and we really need to understand both of those systems and all of those other areas, genetics and epidemiology, so that we can put all of those pieces of the jigsaw puzzle together and stop MS in its tracks. So we know that there are now approved in Australia 9 different disease-modifying therapies. They all target the immune system, and they are all variously efficacious in stopping the relapses of MS. Some of them are showing some progress in stopping the progression of MS, or not necessarily reversing it, but slowing down and pushing out those milestones of the progression of MS. But they all come with side effects, some very mild, some more risky and more extreme. So there's more that we can be doing. There's more treatments that are coming through the pipeline, refining those treatments, targeting the immune system more carefully so that we can actually reduce those side effects and target the disease more effectively. Unfortunately, for progressive MS, there are no approved treatments at the moment. But as Marcus mentioned, there are more and more clinical trials coming through, testing some of the current therapies that are available to see if they can slow progression, and also new types of therapies coming through that are under testing for progressive MS. And hopefully, as I mentioned, I'll be able to mention at the end, there are some big hurdles that we need to overcome to really tackle that problem of progressive MS, and there's some excellent progress happening there. So MS Research Australia is the national research arm. MSWA, as Marcus mentioned, is the biggest contributor to our funds. And we work alongside all of the state societies around Australia who contribute to the funds and work with us to ensure that we are being able to support the strongest research in Australia and build the ability of Australia to do MS research. There have always been good MS researchers in Australia, but we need more of them. And MS Research Australia has several different granting mechanisms that we use to encourage more researchers to come into the MS field and to build their ability to do strong MS research. So we give researchers project grants. These last 3 years, they allow a researcher to pursue a particular avenue of research. We have scholarships and fellowships. These are to get those fresh young minds into the field and keep them working on MS research rather than going off to work on some other area of science. We have incubator grants. These are very small grants, but they are very important in terms of giving researchers the ability to get a new, completely novel idea off the ground and get their research happening. With the seed funding that we give them, they're able to get pilot data that enables them to win a much bigger grant so that they can pursue that new line of research. And with some recent analysis shown that when we fund researchers with an incubator grant, they multiply that funding by 27 times on average in winning more grants from the government and from MS Research Australia to pursue that research. So it's a really effective way of getting new research happening. And the other thing that we do is bring researchers together. Researchers around Australia, some of them are working on the same problem, but they have smaller numbers of people to work with, and so bringing them all together actually increases the power of the researchers to get to the actual real answers, get real statistical power behind their work, and get the results. So this, I don't expect you to be able to read all of those spots, but this just shows that we're covering the whole of Australia and in terms of the researchers that we fund and work with, and we also include researchers in New Zealand in some of our bigger national collaborations. I suppose you could call them international collaborations, as New Zealand is not yet a state of Australia. So, as I've mentioned, It's a complex disease and we need to cover many different areas. So I'm going to try, in the short time I have, to zoom over some of those areas of research that are listed up there and give you a bit of an insight into really the breadth and the progress that is happening. Now, genetics is a big area. We know that MS has a genetic component. It is not a genetic disease in the sense that it's passed down through the generations like some genetic diseases are. But we do know that your genetic background, the collection of genes that you have, can put you at a higher risk of developing MS. And we know that some researchers, Professor Broadley in Queensland did a big study. He combined the data from many genetic studies, and showed that the increase he sort of gave some numbers there to the increased risk that you'll see in family members of people with MS. So the more closely related you are to a person with MS, the higher your risk of MS is. But you'll see that even for an identical twin, the risk is not the same. So an identical twin shares all the same genes, but they don't necessarily also get MS. So what we know is that it's about 50% of the risk of you developing MS relates to your genes. The other 50% is due to other factors, some of which I'm going to touch upon later on. So researchers all around Australia, including in Perth, Professors Alan Commode and Bill Carroll, have been collecting DNA samples from people with MS, and they combined their samples with everybody else around Australia and did a huge genetic study of people with MS and discovered 2 or 3 genes that are implicated in increasing your risk of MS. And then they combined their DNA samples with thousands of others from around the world in the International MS Genetics Consortium. And we now know that there are around 100 genetic variations, little typing mistakes in our DNA that mean that we're more likely to get MS than somebody else. Now, each one of those genes has a very small effect in increasing your risk of developing MS. But biologically, each one of those genes tells us something really important about how the disease works. And so we now know the majority of those 100 genes relate to cells of the immune system. They're involved in controlling cells of the immune system. So there's been a bit of an argument for many years about MS as to whether it starts underlying in the nervous system or it's something going wrong in the immune system. But the genetic data really clearly shows that the immune system is a key player, and it's a major fault when it comes to the development of MS. It confirms some of the genes that were discovered actually fit in really perfectly with some of the lines of research that have been going on. It helps to build on that research, and it also gives us new clues of other molecules that we can chase to see whether we can develop new treatments that target those molecules. We're not at the stage yet where we can do a DNA test on everybody and say whether you're going to get MS, you're not going to get MS. But it helps us to build up a picture. It helps us to understand the disease better. And what we really need to do now, we have this list of 100 genes, where do we go from there? And what we really need to do is go back down to so we've gone out and looked at it, at the big picture, and now we've got to go back down and look at each individual gene on its own and see what it does. What do the genes do? Which cells are they working in? And can we target those genes with drugs? And some of those genes are now being pursued by members of that genetics consortium who are working on 2 of those genes there that they discovered in Australia, and they're pursuing them further. And I'm going to come back to vitamin D later on as well. The interleukin-7 receptor gene, IL-7R there, is a very interesting gene as well, because it actually tells us why some people respond to the interferon medications and others don't. So this is that pharmacogenetics idea where your genes determine the way you respond to drugs. So we're getting some very interesting insights there that might help doctors to tailor medications better to the individual based on their genetics. Now, Professor Wilton here at the Murdoch University in Perth received an incubator grant from MS Research Australia And he has been working on the idea that we might be able to switch some of those genes off, actually regulate their activity. And he's been using some really interesting genetic tools to turn those genes down, like turning off a tap, and stop their activity. And one of the genes he's focused on is part of the molecule that is on the surface of immune cells that allow them to pass into the brain. And that's the molecule that is targeted by the drug natalizumab or Tysabri. So he's looking at that gene to see if we can actually... Tysabri is a fairly wide-hitting molecule. It sort of targets and then suppresses the immune system quite broadly. What we really want to be able to do is use a bit more of a fine scalpel to work on MS rather than just whacking the immune system out altogether. And so he's working on this genetic technology to see if we can turn those genes down and stop the impact in the body. The immune system itself is very complex, and there's absolutely no way I'm going to give you a lecture on the immune system here today. It's just, it blows my mind sometimes when I try and work out what's happening in the immune system. We know there are T and B cells that respond directly to specific types of pathogens. They are the ones that are mistakenly responding to myelin in your body. There's also the innate immune system, which is made up of these cells called macrophages, and in the brain there are microglial cells and astrocytes that also act as immune cells. And it's become increasingly clear that the innate immune system in our brains is also playing a major role in the progression of the disease. And so there's a huge focus now on trying to tackle that aspect of the immune system. The current drugs tackle the T and the B cells, but we need new medications that tackle those innate immune cells in the brain. We need to know how they're working. We need to know what they are doing to cause progression, and we need to know how to switch them off. So there are some really important areas of research happening to tackle that problem, and some interesting medications coming through to very early phase clinical trials that are tackling the innate immune system as well. Now, in the period where the myelin is lost. So in relapsing remitting MS, the myelin is attacked, it disappears, and the nerves are left exposed and short-circuited. And the body is able to repair those fibres, but eventually it loses the ability, and that's part of the reason why MS progresses, because the ability to repair after each attack diminishes over time. So we need to be able to encourage the brain to remyelinate, to put more myelin back around those exposed fibres. And while it's doing that, we need to protect those wires, because when those wires are exposed and not wrapped in myelin, they're actually more vulnerable to damage. So we need to do two things in MS to protect the nerves. We need to get the myelin repaired, and we need to stop the nerve fibres from breaking down. Now, Stephen Prochatos at Monash University in Melbourne has made some really interesting progress in this area. A couple of years ago, he found a molecule that is part of a cascade, it's like a demolition gang, breaking down the nerve fibre after it's been damaged. And that cascade clears away the nerve fibre and leaves nothing behind. And you can't come back from that. You can't repair that after it's happened. So the molecule he found was a key part of that cascade, at the top of the cascade. And he has found a way that you might be able to block that cascade from happening. So keep that nerve fibre alive and intact, and leave time for the myelin to repair. So the drug that he's been working on is actually approved by the TGA, by the Therapeutic Goods Administration, for other diseases. So it's sort of repurposing a drug, which makes things faster. If you've got a drug that's already been through safety trials for other diseases, it makes things faster if you want to try and use that drug for another type of disease. So he's now working on preclinical studies in animals to see if he can use this molecule to stop the nerve damage in MS. And hopefully, because it's already being used for other diseases, it'll speed its progress into clinical trials. So it's a couple of years now since he discovered that molecule, but that's perfectly normal in the progress of research, that these things take time to happen. So it's a really interesting area, and it's a sort of watch this space idea for Stephen's work. Now, I know that everybody is very interested in the idea that stem cells might be able to be used in MS to repair the damage. Now, there are two ideas being pursued in stem cell research for MS. One is the idea that we might be able to use transplants, and the other is that we might be able to encourage stem cells that are naturally resident in our brain to actually get on and do the job better than they're currently doing. So the work that's been done so far internationally on stem cell transplants is suggesting that stem cells aren't actually going in and rewiring the brain and remyelinating. They're not repairing the damage. What it appears that stem cells do when you infuse them into the person's body is that they actually have immune modulating properties. They calm down the immune system and make the environment more friendly so that repair can happen naturally. So those cells don't become part of the brain, but they allow the repair to happen. And this work has mostly been done in animals, and there have been very few small-scale trials in humans overseas of different types of stem cells to see if we can pursue this and use stem cells as a sort of immune therapy. Now, the other type of stem cell that is the only type of stem cell that's currently used in MS is the bone marrow stem cell, or hematopoietic stem cell. So this is basically a bone marrow transplant. The doctors take out your own bone marrow, store it, grow it in a lab, and then people with MS will have chemotherapy, really aggressive chemotherapy, to obliterate the immune system, and then their own stem cells are replaced. And the idea of this is like rebooting your computer. It's rebooting the immune system, and hopefully when the immune system reconstitutes, it comes back, it's more tolerant of your own body and doesn't attack your own body. So there's been a huge amount of research around the world, and hundreds of people have been treated overseas. Around 40 people have been treated in Australia using this type of therapy. It is a very aggressive type of treatment, and the outcomes from the treatments are still relatively uncertain. We're beginning to know that it works better in people who are younger. It works better in people who have active inflammation in the brain, so people in the earlier stages of the disease rather than people who are already in the progressive stage of the disease. But it's a very aggressive treatment. It comes with a high risk of very serious infections sometimes, which will result in death. And so it's not a treatment to be taken lightly. It's reserved for those people who have failed on all the other standard medications for MS. And there have been, as I mentioned, very few people treated in Australia with this form. MSWA very generously provided a grant of $100,000 to MS Research Australia so that we could set up a registry. We can't do a clinical trial. We don't have the funds and the capacity in Australia to do a clinical trial at this stage. But what we can do is gather as much data as we can on the people who have received this treatment and analyse that data so that we can get a better understanding of which people it's most likely to work in and what kind of benefits we can expect. At the moment, the data is very mixed in terms of the potential outcomes. So this is a treatment you don't want to undertake when the risks are very high and the outcome is uncertain. So we need much, much better data on that. The international consortium are working on their data. We're contributing to that with MS Research Australia through the registry, and hopefully over the next couple of years we'll get a more clear idea of where this type of treatment is most appropriately used. Other types of stem cells are also being tried. Mesenchymal stem cells come also from the bone marrow. There's some studies going on to use these stem cells without the need for chemotherapy. So these stem cells can be infused. Again, it appears that they modulate the immune system rather than repair the damage. I just wanted to mention Kayleen Young here. She received an MS Research Australia project grant from us a couple of years ago, and she has been doing some fantastic work. We knew she was fantastic, and she's just the other day received the Metcalf Award for Stem Cell Research from the National Stem Cell Research Foundation, which shows that she's a very strong researcher and we put our money behind the right person. She's been looking at the stem cells that are resident in the brain and the way they naturally turn over. There's a natural death and replenishment of myelin in the brain, and she's been trying to understand that normal process so that we can understand how to make it work better and to repair damage in MS. So I think she is one to watch. She's very young, she's been very successful with her research so far, and I think this is quite an exciting area to watch. I think the idea of getting this natural repair mechanism to work better is something that we really need to think seriously about, and I think it's one of the key ways to go for the future. Now, I keep touching about on risk factors. I've talked about the genetics, and there are many other factors that contribute to a person's development of MS. We know that the strongest risk factors associated with MS to date, where the data really shows that they play a role, is smoking, vitamin D, and the Epstein-Barr virus. Epstein-Barr virus is the virus that causes glandular fever, or the kissing disease. None of them on their own is the answer. It's not the cause of MS, but there's probably likely to be a combination of these genetic factors, these risk factors, the vitamin D, EBV, and smoking, and other risk factors that we're not fully aware of yet, that all combine together in a perfect storm to create MS in any given individual. Professor Pender in Queensland has been doing some amazing work. His whole career has been devoted to trying to understand how EBV and the immune system interact to contribute to MS. And he has found some quite convincing evidence that people with MS actually have a genetically lower percentage of cells in their blood called CD8 cells. CD8 cells are the ones that respond to viruses and kill viral infected cells. And so he's been working on the theory that these cells are deficient in people with MS and make them more vulnerable to the effects of EBV. If you test anybody in this room, 90% of people in the healthy population have been exposed to EBV virus at some point in their life. 99% of people with MS have been exposed to EBV. So EBV seems to be necessary, but not on its own sufficient to cause MS. So it's understanding what's different in a person with MS that allows EBV to contribute to the development of the disease. Michael's been working on a really interesting new treatment to restore that CD8 response to viruses, and he's working towards a clinical trial, a safety trial, to see if this is going to be something that we can pursue as an effective treatment for MS. Professor Commode here in Western Australia has also been working on trying to understand the interaction between the immune cells, the Epstein-Barr virus, and our genetic background to see how that influences the immune cells in our body and contributes to MS. And he's been making great progress. He's been profiling the levels of different types of immune cells in the blood of people with MS, and he's still working on this project. It's ongoing till next year, so we have to sort of watch this space. But it should give us a way of sort of predicting and pulling together those different environmental and genetic risk factors to bring the picture together and get a better understanding of the cause of MS. And prevention is better than cure in my mind. And one of the ways we're looking at prevention is to see whether we can take one of those risk factors, which is very easily modifiable. We can change this risk factor in people. Can we change the impact of MS in society? And this risk factor is vitamin D. Vitamin D is synthesized in your skin in response to ultraviolet light. And we know that the incidence of MS throughout the world changes as you get further away from the equator. So the further away you live from the equator, the lower the incidence of UV light and the higher the incidence of MS. And there's been many theories about this, why this has been for many years, whether it's an infection, whether it's some genetic factors of people who live further from the equator. But the evidence is becoming extremely convincing now that it's the levels of vitamin D. We know there's lots of evidence that people with MS or people who present with the first symptoms suggestive of MS are deficient in vitamin D. We know that people who have lower levels of vitamin D have slightly higher relapse rates and slightly more aggressive relapses. And so there's lots and lots of circumstantial evidence that low vitamin D is a risk factor for MS. But what we don't have yet is any convincing clinical data to say that if you supplement someone with MS, you're going to reverse those problems, or if you supplement the whole population with vitamin D, that you're going to stop MS from happening or reduce the incidence of MS. So we have been able to work with the MS societies. MSWA has been the single largest funder to the MS prevention trial. Other MS societies around Australia have contributed. We've had trusts and foundations contribute to this. The data is very convincing, and we really need to do this clinical trial to get a definitive answer. I know that many people with MS already go and get their vitamin D levels tested. They'll already be supplementing with vitamin D, but we don't know what is the most appropriate dose, and we really don't know what benefits can be expected from any given dose of vitamin D. So this clinical trial, which has already commenced, we started it in late last year, and we have 20 sites around Australia and New Zealand who are enrolling people with their first clinical episode. So these people don't have a diagnosis of MS, they have what's called clinically isolated syndrome. If they have a second episode, either on an MRI scan or a clinical episode, a neurological relapse, then they will receive a diagnosis of MS. So in that window between suspecting MS and getting a definite diagnosis of MS, we're going to try and treat people with vitamin D to see if we can delay or prevent that diagnosis. And so we're testing 3 different doses of vitamin D against placebo, which is an empty capsule. Time's almost up. Oops. And we're going to see whether we can alter the course for these people. We have to be very patient. The results are not expected till 2017. We need to enrol 240 people around Australia who will be randomly assigned to one of those 4 doses, and we will then be testing we'll be doing MRIs, doing blood tests, looking at their immune system, and recording relapses and looking for relapses on MRI to see what impact the vitamin D has. And this trial has been designed by a team of researchers from around Australia. The steering committee includes Professor Bill Carroll here in WA. There is a trial site here at the West Australian Neuroscience Research Institute and around the other states as well. And we will, over the next 3 years, enrol those people and see what results we can get. So in the meantime, if you have concerns about vitamin D, it's as well to get your vitamin D levels measured and to make sure you're sufficient in vitamin D. But until we have the results of this trial, we can't give an answer as to whether that really is going to have any impact at all. There's also a lot of interest in diet, and diet is notoriously difficult to get proper clinical evidence and data to suggest whether one particular diet is better than another. I know there are many diets out there on the internet and books about advising on diet for people with MS, but we don't have a lot of clinical data on dietary factors in MS. But one area where Australia has been quite strong is following people over a long period of time and measuring all of their lifestyle factors and measuring all of their clinical factors, looking in their blood for different things like vitamin D, looking at their fat levels, and trying to understand the picture of how all of those different factors relate to their clinical picture, the different disease course that everybody presents. And this is Ingrid van der Meij from the Menzies Research Institute in Tasmania, and she has been looking at this cohort of people over a long period of time, people from their very first diagnosis, and kept following them. And one of the things she's been measuring is the level of fats in the blood. Now, you've probably all heard about bad fats. Cholesterol is a bad fat. There are different types of cholesterol and different types of fats in the blood that are bad and some that are good. We need fats in our diet because myelin is made of fat. We need fat to repair and maintain our body. But there are good fats and there are bad fats. So what Ingrid has looked at is this adverse fat profile. So when you look at people with cardiovascular disease, they have what's called an adverse fat profile in their blood. They have high levels of particular types of cholesterol and low levels of other types of fats. And this same adverse fat profile, Ingrid has shown, is associated with a faster rate of progression in MS and higher levels of disability. And she can show that it's not, by looking at the timing of this, because she's looked at it over a long period of time in the same group of people, that the fat profile in the blood, the bad fats in the blood, is not a result of having MS. It's part of why, it's not a result of having a worse type of MS. It's a part of the reason why they've got a worse type of MS, why their MS is progressing faster. This is really interesting, and it's a first step. So don't rush out and go and suddenly change your diet. We don't have the clinical data to show that by suddenly changing your diet you're going to reverse MS or slow down the progression. But Ingrid is now really interested in actually pursuing that and looking at some clinical studies where we intervene in people's diet very carefully looking at those fats and seeing whether we can change the course of MS or slow down disability. It's not going to be the silver bullet. Vitamin D on its own is not going to be the silver bullet. Stopping EBV infections is not going to be the silver bullet. We need all of those things to come together, and that's why we need to focus on all of these different areas of research to bring it together, because one thing on its own is not the whole picture. Now, I mentioned at the beginning that progressive MS is the big problem area in terms of finding better treatments. And it's been recognised that one individual country, one individual researcher on their own is not going to solve this problem. There are quite a few hurdles to overcome. And one of the biggest hurdles is being able to design clinical trials where we can actually measure progression effectively and accurately so that we can tell whether a drug is working. The clinical trials for progressive MS have been problematic because to measure progression with the method we have at the moment, using the expanded disability status score, is a very long-term project. And clinical trials are very expensive. And to measure disability over time and see whether a drug is changing that level of disability, you need very long clinical trials that are going to be far too costly to do. So the idea is to look for biomarkers, other measurements. Can we look at brain scans? Can we look at the way the brain might be shrinking, and can we measure that over time? Can we see markers of nerve damage in our bloodstream that allow us to measure whether the damage is continuing and whether a new drug is stopping that damage from happening? And so all of those hurdles have been brought together. The MS International Federation have got a group of experts together and identified what these key hurdles are. And now they're bringing together researchers, and they're putting together a funding program to really focus everybody's mind. There's nothing like money to focus a researcher's mind on the biggest problem at hand. So we're really now working towards focusing everybody's mind on progressive MS and tackling all of these hurdles, bringing together the best minds in the world to tackle these hurdles and get these clinical trials happening more effectively so we can tackle MS, progressive MS. MS Research Australia is contributing to this Progressive MS Alliance through the steering committee and through the grant process, and we hope to be getting more deeply involved with this as the project gets further down the track. So rest assured, there is a huge effort underway to tackle this big problem. Really, really quickly, I'm running really out of time now, I just wanted to touch on some areas of research about helping people to live well with MS. All of what I've been talking about is all well and good, but it's a slow process, and research is meticulous, it's painstaking, and it takes time. But in the meantime, I can hear people crying out, "That's not going to help me, my MS is progressing, I have these symptoms, what can we do about it now? I need to be able to get on with my life." And so that's where social and applied research comes in. It's one of the key pillars of MS Research Australia's research strategy, as I showed you at the beginning. It's looking at things like the economic impact of MS, how it impacts on people's employment opportunities, understanding the needs of people with MS and whether they're being met and whether those needs are being satisfied. It's looking at physiotherapy, it's looking at training the brain memory, and thinking is affected in MS very frequently, and supporting people with MS. What are the best ways of supporting people with MS? So there are many, many services available, and as Marcus mentioned, MSWA is providing many excellent services, but we need to keep making sure that those services are the best possible available, and that we're using the most recent knowledge to provide the best services. Fu Huang here is a physiotherapist, and he's working at the Neuroscience Research Australia Institute in Sydney, and he's been trying to investigate what is the collection of symptoms that is most likely to make a person with MS have frequent falls. Now, you might think this obvious. I've got foot drop, I've got a weak leg, I've got problems with my balance. All of those things can make a person fall. But it's really important that we understand the most common, that we get the picture of the full collection of symptoms that are contributing to falls. Falls have a big impact on people with MS, and they can result in further injury and disability. So Fu has been analysing over a long period of time the symptoms that contribute to falls, and he's now designed a clinical trial to address the most common collection of symptoms that contribute to falls, and he's now testing that in people with MS at the MS Society in New South Wales. Louise Koziski has been looking at continence. It goes unreported, people don't want to talk about it, and doctors are busy focusing on all the other problems, and they don't generally ask about this problem. So if you don't tell and the doctor doesn't ask, it's just going to go unlooked after. So Louise is a continence nurse, and she's been working on a very simple screening tool that can be very easily done by nurses in the clinic to identify people that have continence problems and then make sure they go down the correct pathways of intervention. Are you going like this? Pathways of intervention to improve outcomes. Continence can have a massive impact on people mixing in society, in employment, and in general well-being. So it's really important that these problems are addressed, and Louise's project will help to make sure that that happens in the best possible way. There are researchers here in Western Australia who are doing some excellent research on cognition in MS, thinking and memory problems in MS, and trying to develop new interventions that will help people to reduce the impact of that on everyday life. And I think I am going to shut up now there. I'm going to stop. And I know I have whizzed over a huge array of topics there, but I hope I've been able to give you a bit of insight into the complexity of research, the reason it takes such a long time, and that there is so many different areas of research being pursued, and there is progress being made. So I'm very happy to answer any questions, and thank you for your attention. There's a very big cohort that have been studied in the European Bone Marrow Transplant Registry, and they have come up with a sort of collection of criteria that suggest who may be more likely to benefit and who is much less likely to benefit from the treatment. So, and this is all just statistical. So when as researchers, we love our statistics, and so when it comes down to an individual, it's very hard to predict. But on a statistical level, it is people that who are usually younger than 40, people who have active, so when you have an MRI scan, you sometimes have a gadolinium infusion that shows up where the lesions are. So if you have a gadolinium enhancing lesion in the brain, it means that there's active inflammation going on, that the blood-brain barrier is open and damaged, and that the immune cells are going in. So people who have gadolinium enhancing brain lesions are more likely to respond. Now, as you go into the progressive phase of MS, there are fewer and fewer gadolinium enhancing lesions, but the progression is continuing. So what it appears is that the bone marrow transplant, the HSCT, is treating the inflammatory response, the active inflammation, rather than the progression. So it stops there is evidence that in some people, after they've had the treatment, they don't have any further gadolinium enhancing lesions after the treatment. So it does seem to suppress the inflammation in some people. If they're younger, if they have active inflammation, it seems to suppress it. It doesn't appear to undo damage that's already done. So if you have permanent damage from disability from MS, the HSCT is not going to reverse it. But it appears in some people to stabilise their disease. But the trick is getting much more accurate information about who is going to respond, who is it going to help stabilise their disease, and who is it not going to work for. Because, as I mentioned, it's a very high-risk treatment. It's centre by centre, they have different death rates, but some centres have a 1% death rate, some have a 5% death rate, and some have had 0 deaths. And so it's centres that are very experienced at doing this type of treatment in people with MS are having better results in terms of the side effects, the risk factors. but it's still, on average around the world, it appears to be about a 1.3% death rate from the treatment. It knocks out your immune system completely, so you're at high risk of very severe infections in that period. And there are other longer term risk factors in relation to bone marrow transplants as well. So it's definitely not to be undertaken lightly. With the registry, we're working on sort of developing some guidelines, some criteria that will help people determine whether, and doctors determine whether a patient might be eligible for this treatment or not, whether it's a sensible thing to try. But it's really reserved for those who have failed all the other therapies. It's much more high risk than, I know there's many serious side effects with some of the MS medications, but the death rate from HSCT is much higher than the side effects, the risk of side effects in those other types of therapies. So it's really a very small subpopulation of people with MS that it may be a viable option for. Unfortunately not. As I mentioned, there's those 100 genes that have been revealed, and what we were hoping to see from those studies is some biological factor, some genetic factor that determines whether a person has progressive MS and someone who has relapsing remitting. But it didn't tell us anything about who gets what sort of MS and who gets more aggressive MS. It tells us, in the thousands of people who donated their DNA to that study, there were people with primary progressive MS, relapsing MS, secondary progressive MS. The whole spectrum was in the study of sufficient number that if there was a signal in there, we should have been able to detect it, but nothing came out. So we know from that genetic study that the immune system is important across the range, and as yet we don't have a clue as to why some people have more aggressive or less aggressive disease. I think the Australian recommendation for the highest safe dose of vitamin D, I think is 3,200 international units of vitamin D is the Australian recommendation. We do know from studies of bone health, for example, that doses up to 40,000 international units per day are okay. 10,000 is safer. When you get up to 40,000 international units of vitamin D, which is an extremely high dose, the risk of side effects relating to calcium are much higher. So if you're taking extremely high doses, you shouldn't also be taking a calcium supplement because it causes hypercalcemia in the blood. So you get high levels of calcium in the blood, which can cause kidney problems and other problems in the body. So yes, there is a risk from taking too much vitamin D. And that's why we need to sort of do the study in people with MS so that we know what's safe for a person with a healthy individual may not be safe for a person with MS. So we need to do that study to get that data. But other studies tell us you can take quite high doses up to 10,000 without hitting serious adverse effects. But again, it depends on your own health and your own calcium metabolism and so on. So it's really important if you're planning on taking quite significant doses of vitamin D that you do that in conjunction with your GP or your neurologist. Get your levels tested, check that you don't have any other risk factors that might put you at risk of having hypercalcemia or kidney disease and so on from taking that high dose of vitamin D. It's really important to make sure you do that in conjunction with a medical practitioner. I think I only know something about it in that I haven't seen any convincing data that suggests that there's clinical evidence that would say that that's an effective treatment. I know that there are sort of therapies out there, clinics offering these types of therapies, but there's been no clinical testing, no clinical trial to show that it's actually effective. There might be anecdotal evidence so individuals saying I felt a benefit after this treatment. But there isn't, as far as I know, any clinical evidence that it's effective.